Okay, so now let's proceed to the temperature boundary layer. Okay, so if we have this kind of velocity boundary layer in external flow, then let's now proceed to the temperature boundary layer. Okay, so in a similar way, let us consider a free stream on the left, like what we have done last. So say this is our free stream having this temperature profile. I mean temperature of the fluid, the temperature profile of our free stream having this our y and x axis. Say this is our flat plate or surface. Okay, so initially having this free stream on the left, and this has a uniform temperature profile right before it comes in contact with our plate. Okay, say we have now the our plate has a temperature Ts, or the let's call it Ts. Okay, and what we call an isothermal flat plate with a temperature Ts is greater than the fluid if this Ts temperature of this plate is greater than the fluid. Let me change the color. Since the temperature of the surface is greater than, meaning it is hotter, so let me change the color into blue, and having this flat surface as red, indicating that it has a higher temperature than the stream. Okay, so in this case, the our Q, or the heat flux, would be from where? Right, so from our solid surface going to the fluid stream, right? So the heat flux be from the solid surface going to the fluid stream in a decreasing temperature, right? So the moment the fluid stream comes in contact with the hot surface, so this stream comes in contact with this hot surface, the temperature of the fluid layer at the interface will increase, right? So what will happen to the temperature of this fluid stream, right? So from this profile, the one that is in contact with this hot surface will increase its temperature, right? So from here, this profile will increase its temperature, right? Because it comes in contact with this hot surface. Okay, and what will happen to the layer? Okay, so in turn, this first layer exchange energy with those adjoining fluid, with this adjoining fluid, and so on and so on. Okay, so from here, we can now have this kind of profile. Okay, oops. Sorry for my drawing. Okay, right? And so from this, the temperature profile will looks like this. Okay, having this condition that our solid, I mean our flat plate has a higher temp than the fluid, then the fluid that is in contact, direct contact with our hot plate will have a increase in temperature, and then the first layer, this layer upstream, will exchange energy with those adjoining layer, thus creating this kind of profile, right? Okay. So we can now see the temperature gradient on our stream. Okay, and similarly, a boundary layer is developed, which is also a function of x. So if we trace this free stream, will move like this along x. Then from here to here, temperature. So at that point, at that layer, the exchange of energy from layer to layer will go on and on until such time that the exchange is became negligible. That's why we have this equal now distribution of your temperature profile. Okay. Okay. So this boundary layer is termed to us the this boundary layer is termed to us the layer. Yan, ganyan. And below this layer, the region where the heat flux by conduction is significant. That's why creating this kind of profile, right? And affecting the temperature profile. And the region above this boundary layer is where the heat flux from the surface, from this surface, is no longer no longer significant. It's like it is no longer felt, the temperature from this profile. Okay. The formation of this thermal boundary layer is because of the what property? What I call this? Yeah, it's because of the thermal property of the fluid, such as the thermal conductivity, the specific heat, and what else? The density. Yeah, and the density. So the thermal conductivity relates how much heat is to be conducted, right? We're in our CP, and our density, or our specific heat and our density, relates how much heat is to be stored or maintained. Okay. Okay, and once again, the ratio of the two is what we call the our thermal diffusivity. Okay. So this is again the concept of the boundary layer in terms of the temperature boundary layer. Okay.